Welcome to a lesson with Dr. Powell. Let's take a look at how we can compute the derivative of something like 2 to the x or a to the x in general here. What's the derivative of this function? Let's look at a particular example, 2 to the x. We're going to rewrite 2 to the x as e to the natural log of 2 times x, because we can do that, right? E to the x and ln of x are inverse functions of each other. And if you plug in ln of 2 into e, they undo what each other do and just outputs 2. This is the same thing as 2 here. So 2 to the x. The exponents multiply. So using the chain rule now, we think, okay, e to the natural log of 2 times, well, that's a constant times x, constant times x. So the derivative of this, well, we have e to the variable, right? The derivative of e to the variable is e to the variable times the derivative of the variable, which is constant. So constant times x, well, just that constant, like mx plus b, right? Just that constant there. So natural log of 2. So then we just keep with our what our variable is, ln of 2x, but notice that this, right, this was all equal. This is really just 2 to the x. This part's just 2 to the x. So notice, when we take the derivative of a to the x, what is it? It's just simply the natural log of a multiplied a to the x. The derivative of e to the x was just simply e to the x, but notice how it coincides. ln of e times e to the x. ln of e is 1. Ah, very nice. E is actually defined to be the number such that this happens, such that you get the derivative is itself that this number is just simply 1. That's one way of working on it, at least thinking of in the limit computation. You can think of e as being the number such that e to the h minus 1 over h limits to 1. That's another way of that actually is equivalent to this idea in some sense or another. But of course, there's a little bit more to be done here, but in that particular definition, and I won't go through that here. But nonetheless, we know that the derivative of a to the x is this right here. Thanks for watching.